this video I'm going to show you how to bench test the Samsung BLDC fan motors, or brushless DC fan motors. So I got a few different motors here. They all run on 12 volts. They all have 3 wires and the wiring color is all the same on all 3. Any of the Samsung DC fan motors I've seen all seem to have the same color wires, the black, red, and white. So here we have a condenser fan. I'm not even going to test this one because I know some varmints got in there, chewed the wires up on it. I know this one's no good. No point in even testing that one. This fan here is, I know it's seized up. It was making noise. It's seizing up. We can try testing that and see what happens. And then this one here I know is a good fan out of the fridge section. So let's start with the freezer fan motor. So again, we've got our red, white, and black wires. Red wire is 12 volts DC from the PCB to the fan motor. Black wire is going to be 12 volt negative coming from that main board or PCB to the fan motor. These are the two that are going to make it spin. The white wire is a feedback signal. This sends the RPM or the fan speed back to the PCB to let it know, yes, I'm spinning. If it doesn't get this signal back, it will pulse the fan on and off several times before giving up. And it'll give up for about 10 minutes before it tries again to get that fan motor going. So don't get fooled with that, because sometimes the PCB is actually disabled the power to it. So you might be testing for power coming from that main board of this fan and you may have nothing. But it's because it's been disabled because the fan itself is not spinning, or it's not seeing it spin. So anyways, let's get to bench testing. So we're going to bench test this fan. It's a 12 volt fan, but we're going to bench test it with a 9 volt battery. We're low DC voltage here, so we don't have to worry about getting any shocks off of this. You can touch across there, no problem. It's not going to hurt us. Alright, so we're going to go black to black, red to red, and then we should be able to fire that fan up. So red, black, but we got nothing. Fan doesn't want to go. I'll make sure that I have voltage there. 8 volts, pretty close to 9. Oh, it's trying to go there. There it goes. So, fan will spin, but we know this fan is not good. Okay, we got the good one. Let's try the good one out here. Get rid of this guy. Okay, same wire colors. And I know, again, this is a good fan. Good fan motor. Works. It was working in the fridge. So I'll connect my red to red, black to black, black to negative, red to positive, and our fan spins. So we know this is a good fan. It's capable of spinning. What we don't know is, are we getting a feedback signal on this white wire? If you were testing this in the fridge and the fan was spinning, you should see that 5 volts coming from the main board on this wire being reduced. The faster the fan spins, the more that voltage is going to be reduced coming back to the main board. Alright, but we can bench test that and get an idea of what's going on that way as well. So what we're going to do is take our meter. Here, I think I got the meter in view. We're going to go negative onto that white wire, positive to positive, and then we'll get the fan spinning. We got over 5 volts happening there. But remember, this is a 5 volt reference. We're using a 9 volt battery. The numbers aren't going to be correct. It just kind of gives you an idea if you're getting any kind of signal on that at all. Now I'm going to jam this fan up and try it again. So now we're up to 8 volts. Again, like I say, we're working with a 9-volt battery here, so in the fridge that would be closer to 5 volts. You're getting 5 volts on that feedback signal and the fan is spinning. There's always a problem with that circuit depending on where you're testing it, or the fan itself, the Hall effect sensor in the fan is defective. I'll take that out, spin it up again, and we've got about 5 volts. Again, voltage numbers are going to be off because we're using a 9-volt battery and it's not getting that 5-volt reference, but it still gives you a good idea what's going on there with this. We are getting a signal on this line, so this is a good fan. Head on over to ApplianceTechInfo.com for more appliance repair information. And if you enjoyed this video, don't forget to like and subscribe.